Hello everyone. Today what we're going to do is we're going to learn how to multiply polynomials by using the distributive property. So that's going to be our main thing of learning today, is using the distributive property. So what we're going to do first is I'm just going to go through an example not using the distributive property of how we'd have to simplify something like this. So for this guy we've got two of these things in brackets. So I'm going to write x plus 3 twice. So that would give me two of them. Then I've got 3 of the 2x minus 5s, the weird 2, plus 2x minus 5. So I've got 3 of them, and I'll put them in brackets. The brackets here, because we've got adding between all these, the brackets don't do anything. So they are just there for looks. So I'm going to have x plus 3 plus x plus 3 plus 2x minus 5 plus 2x minus 5 plus 2x minus 5. Okay, so then what I can notice right away is I've got all of these x's are like each other because they have the same variable, the variable being x, and they're all to the same exponent, which is 1. So what I'm going to do is, remembering that there's a 1 in front of all these x's, I'm going to have 1x plus 1x, which is 2x. 2x plus 2x, which could give me the 4x. 4x plus 2x is 6x. 6x plus 2x is 8x. So I'm going to have 8x. Then I've also got all of these numbers that don't have variables. So those are also like terms. So plus 3, minus 5, minus 5, minus 5. And I know there's some issues with negative and minus. Really it's the same thing. So I'm going 3, so positive 3 plus 3, which should give me 6. 6 minus 5, or 6 and negative 5. So 6 minus 5 would be 1. 1 minus 5 is negative 4. Negative 4 minus 5 would be negative 9. So this would be 8x negative 9, or 8x minus 9. So note when I'm doing this that the number gets the whole positive with it. So when I'm looking at the 3, I'm looking at plus 3. The 5, I'm looking at negative 5. That's where that operation is coming from. It's always the sign in front of the term. Same with the x's. So obviously the first one doesn't matter because it's just positive 1x, but the second one, I'm looking at plus 1x there. So it's 1x plus 1x plus 2x, and so on and so on. So I'm just using like terms. So the point of what we're doing today is surely there's got to be a quicker way to do this, than to write out 2 of these and 3 of these. What if this was an 8? I'd have to write it out 8 times. And what if this was a 12? I'd have to write it out 12 times, or something even bigger. It would be too crazy to work with. So there's got to be a shortcut. So what that brings us to is the distributive property. So what we're going to do with the distributive property is we're going to do a numerical example first. So let's say that we had an example, and let's say we had 3 plus 5. So we could easily work that guy out. We know bed mass. We're going to do the brackets first. So this would be 2, and then in brackets, the 3 plus 5 would give me 8. And then I'm going to multiply, so that gives me 16. Okay, we know how to do that. This, using bed mass, would not work up here in our first example because I've got an x. And I can't add x plus 3 because I don't know what x is. It's a variable. I don't know what it is. So what I'm going to do is, we know that this guy works out to 16, so I'm going to propose a different method. So here's the other method. 2, so same problem. 3 plus 5. So what I'm going to do is I'm going to multiply 2 times 3. Because I know I'm going to have, if I were to write this out like we did up here, I'm going to have 2 3s. So it's going to be 2 times 3, because there's 2 of them. So 2 times 3 is 6. Plus, I'm also going to have 2 times positive 5, because I know when I expand it out like up here, I would have 2 5s. So 2 times 5 is 10. So now I'm left with just 6 plus 10, which is 16. So it works. So that's the distributive property. And what we would say in words is that multiplication distributes over addition or subtraction. So multiplication distributes, and that's that word. Distributes, or the distributive property distributes over addition or subtraction. So what that means is, if I'm distributing this 2, using the word distribute, if I'm distributing this 2 into this bracket, everything gets multiplied by 2. So this is 2, it's not written, but it's 2 times that bracket. So 2 times everything in the brackets. Everything gets multiplied by 2. So if I go up here to this example, and I'm going to use the distributive property over here, so I'm going to write out the question again. So 2x plus 3 plus 3 times 2x minus 5. So everything gets multiplied. I'm distributing the 2, just like if I was distributing papers in class, I would give 1 to every student. Everybody gets a paper. Same with this guy. 2 times everything in the brackets, everybody gets a 2. So this would be equal to 2 times x is 2x. 2 times positive 3 is positive 6. I'm done with that bracket. Everything in the bracket has been multiplied by 2. Same thing with the positive 3. I know it says plus 3, but plus is the same as positive for this case, well, for all cases. So positive 3 times positive 2x would give me positive 6x. Positive 3 times negative 5 would give me negative 15. And now I'm still left with collecting like terms. So this 2x and this plus 6x, they would add to 8x. And then I've got positive 6 minus 15. That would give me negative 9. And lo and behold, I have the same answer for both ways. And I think you would agree with me, this is much shorter. Okay, so we can save ourselves a ton of work, especially as these numbers get bigger. Or as you'll see down here in one of the examples, if it's an x, then we wouldn't know how many times to write it out. So that wouldn't be helpful. So let's go through a couple of the examples here. And pause this where you need to pause it, rewind it where you need to rewind it. I'm just going to go a straight shot here, and you can change the speed as you want. So for this one, now this bracket's got 3 things, but that's okay. Just like in a class of 20, I would have to give 1 paper to every person, all 20 people. This bracket has 3 things in it, so everything's going to be multiplied by 3. So we'll go in order. 3 times 4x squared. So what I do is I multiply the number times the number. It's called, the 4 is a coefficient. So 3 times 4 would give me 12. I don't have any x's over here with the 3, so it's just going to be 12x squared. Then I do the same thing with the 9, the negative 9x. So 3 times negative 9 gives me negative 27. The 3 doesn't have any x's, so I'm just left with the x, so negative 27x. And then 3 times positive 11. 3 times positive 11 is positive 33. I have no like terms in here, so I'm done. These x's, both of the variables are the same here, but this x has an x squared, so the variable, while they're the same variable, it doesn't have the same exponent. So none of these are like terms, we're done. Okay, so that's that one. So that's expanding. Simplifying would be if I had like terms, I'd collect like terms. So that doesn't apply for this one. So let's go to the next one. For B, I'm going to multiply 2x times 3x. So 2x times 3x. What I do is I multiply number times number, coefficient times coefficient. So 2 times 3 is 6. So I have 6. And then x times x is x squared. How do I know that's x squared? I will come back to that. 2x times negative 5. So 2 times negative 5 is negative 10. And then x times, there's no x's in the 5, so it would just be x. For this guy with the minus sign, you have to remember that there's a 1 here. Whenever there's not a number written, it's a 1. So this means negative 1 times 7x squared. So negative 1 times positive 7 would give me negative 7. I don't have any x's here, and I have an x squared there, so that would give me 7x squared. And then I'm going to go negative 1 times negative 4. Negative 1 times negative 4, negative times a negative would be positive, so this would be positive 4. And then what I need to do is collect like terms. So I think the only like terms I have here are the 6x squared and then negative 7x squared. Because they both have an x, so the variable is the same, and the exponent's the same. They both have x squared. So if I add those two up, 6 minus 7 is negative 1, so this would be negative 1x squared. You don't have to write the 1. I'm just choosing to. You don't have to. Minus 10x, there's nothing like that, so that's a rewrite, and there's nothing like positive 4, so that's just a rewrite. And that's my answer. So getting back to what I was saying about why x times x is x squared here, I'll do it over here on the side. A little box. So if I'm multiplying x times x, we only have to think about what the exponents are. So the exponent on this x, whenever it's not written, is just 1. exponent on this x, when it's not written, it's a 1. And we know that when we're multiplying exponents and we have the same base, like these guys, I add the exponents. So 1 plus 1 is 2. This gives me x to the power of 2, or x squared. So that's how I know that that's x squared. So I'm just using my exponent rules. For example, C, this one's a little tricky. Order doesn't matter when you multiply. So even though this guy's multiplied after the bracket, he's still multiplied, so he's still going to get distributed. So I'm going to go 5y squared times 2y to the power of 3. So I go number times number, or coefficient times coefficient. 2 times 5 is 10, so that gives me 10. Y squared times y to the power of 3. Just like we did over here when we're multiplying exponents for the same base, they're both a y for the base. I'm going to add the exponent, so it's going to be y to the power of 5. Then I multiply by the second guy in the bracket. So 5 times 4 is positive 20, so positive 20. Y squared times y squared. I'm adding the exponents, so it would be y to the power of 4. And then last, I've got 5y squared times negative 3. So numbers times numbers. 5 times negative 3 would give me negative 15. Y squared, I don't have any y's with the 3 here, so I'm just going to have 15y squared, or negative 15y squared. I don't have any like terms. Everything inside the brackets has been multiplied by 5y squared, so I'm done. There's nothing else I can do to simplify that. In our last example, now I've got some different letters. So all of these ones here we did so far had the same base, so now this one might be a little bit different. So first bracket, so I'm looking right up to there. That's all I'm looking at. The bracket ends here, so only the things in the brackets get the 3a. So negative 3a times positive 4a. So negative 3 times positive 4 would be negative 12. A times a, just like the x times x, would be a squared. Then I go negative 3a times negative b. Negative 3a times, this is a 1 in front. Negative 3 times negative 1 would give me positive 3. A times b, those are not the same base, so there's nothing I can do there. I'm just going to write 3ab. Then that bracket's done. Everything in the brackets have been multiplied by negative 3a, so I go to the next bracket. So negative 2b times a. So there's a 1 in front of the a. Negative 2 times 1 would be negative 2. B times a is ba, or the order doesn't matter when you multiply, so I'm going to put ab just so it makes it look like it matches up with this guy more. I could have written ba, it's the same as that. Doesn't matter. Then I've got to go negative 2b times 3b. So numbers times numbers, negative 2 times positive 3 would be negative 6. And then b times b would be b squared, just like we did with the exponent laws up here with the x's. So then I look for like terms, and the only like terms I have are 3ab and negative 2ab. So then that gives me negative 12a squared, nothing I can do with that guy, no like terms. Positive 3ab minus 2ab would be positive 1ab. I don't need to write the 1. And then I'm left with 6b squared, negative 6b squared, because nothing is like the b squared. Okay, so pause it, watch what you need to rewatch. These are your practice questions here. Hopefully this isn't going to be too challenging for you. I'll be back on Monday and we can take it up from there. Okay.